welcome to Relativity. Take it from me, Einstein was a clever chap. He set out theories of the way the universe and all the stuff around us works. Since then, a lot of other clever chaps and chapesses have essentially proved that this is actually how it does work. The universe Einstein describes is a very strange place, with time and space bending all over the place to fit in with the speed of light. The only reason we don't see any of this strangeness is that in universal terms, we are very, very small and very, very slow. Yes, even you at the back. The idea behind relativity is to set a game in a universe in which all of these strange effects are very apparent. In order to do this, we will change the scales of everything, size, distance, speed of light, but stick to the correct principles of physics. Don't panic. Whilst relativity uses some pretty crazy physics concepts, you really don't need to understand them to be able to play this game. Hopefully some of the physics will rub off on you as you are playing, and you will suddenly start impressing your friends in the pub with phrases like space-time continuum and time dilation. Please note, actual level of impress may vary. Relativity is not responsible for any lack of impression which may occur. Sometimes the game will use phrases like space-time continuum and time dilation. At this point it is perfectly acceptable to adopt a blank expression, nod vaguely, and click to get on with playing the game. Here comes the science! The space-time continuum is all around us, and in us. We are part of it. Now, to visualise it bending in our 3D world involves thinking in more dimensions than our tiny brains were made to handle. However, if we take a 2D world, the bending of it gets a lot easier for us to imagine. After all, we've all bent a piece of paper. So that's what we'll do. In relativity, the universe, the planets, and the creatures on them are all two-dimensional, leaving the third dimension free to get to grips with that space-time continuum lark. So, let's have a look at it.
And here it is. There's not much going on at the moment, is there? Let's add in a planet, shall we? Ah, there we go. The planet is heavy, and all heavy things bend the space-time continuum. In fact, this is what causes gravity. Imagine I've just put a bowling ball on a trampoline. If I put a tennis ball on the trampoline too, it will naturally roll down towards the bowling ball. In the same way, objects will head downhill on a curved space-time continuum. Watch what happens if I add something else to the universe. Let's take a bowl of petunias. Poor petunias. Your planet, and the others you can see, are cleverly avoiding sliding down the space-time continuum into that star by orbiting around it. Now remember the trampoline with the bowling ball on it? Imagine rolling the tennis ball around the bowling ball. Only friction would stop it from rolling around forever. As there is nothing to cause friction between the planets and the star, the planets will keep going round and round, and round, and round, and round, and round and round.
Now let's see the effect of a fast-moving object. As the ship gets going close to the speed of light, which luckily isn't that fast in Relativity Wars, trying to push it faster will not make it travel quicker than this universal speed limit. Instead, any clocks on board the ship will slow down compared to you, the observer. You will notice the time bar on the left changing colour and slowing down. This means that any 2Dians on board will hardly age at all compared to you or I while they are travelling this fast. You may also notice that as the ship gets going faster, it appears to get heavier and heavier, making a greater impression on the space-time continuum. Whoops! This is a space-time wave. Space-time or gravitational waves are predicted by Einstein's general theory of relativity. They may be created by massive objects such as black holes or supernovas, although we are yet to measure one here on Earth. A real space-time wave, if we felt it on Earth, would alternately stretch and shrink distances, gravity, and the passage of time. In relativity wars, space-time waves will be super useful for causing chaos in your enemy's star systems. Well, that's Relativity Science 101 complete. Hopefully now the game will make a bit more sense to you when you play it. And good luck defeating those pesky squishians.